welcome to fresponse.com. Today we're going to do a deep dive into fresponse collect, the client and server version of fresponse designed to collect disk images and data from remote machines regardless of their distance. Alright, so what we've got here is our fresponse management console application. This is what's running on our examiner machine and gives us access to collect servers that are either running on the internet or on our local LAN. First thing we've done is configure those collect servers in the display, and you'll see them at the top. In addition, we've got accounts configured for other data sources, things like Agentless, cloud servers, and cloud files. In addition to setting up the servers, we've also exported an MSI, or Microsoft Software Installer, that we've had either deployed already to remote subjects or will deploy prior to collecting image data from them. fresponse collect is designed to work on remote Windows subjects and collect disk images, profiles, volumes, physical memory, as well as custom content collections. We'll start by double-clicking on an fresponse collect instance and logging into it. Once we log into the collect instance, what we'll get is a view of the items, or of the collections rather, that are configured on the machine. Here we can see we have 3 collections. We're going to head and create a new collection today, which will instruct a remote machine to collect an image of its data to the server itself. Again, the process for exporting an MSI is straightforward and available through the display. Creating a collection allows us to select one or more machines and then to select one or more targets that those machines have in common. The remote machines will push their data to the collect server over virtually any distance using standard internet protocols. So let's create a collection here. We'll call this collection Test 5, and we'll select a subject. The subject that we select will have a list of targets accessible to it, and that list will appear here in the drop-down. As I indicated earlier, we can collect profiles for individual users. We can create custom collections based on specific folder paths and file names, disks, or volumes. In this instance, we're going to go ahead and select Disk 2 to collect a full device image of its contents. Images collected either of disks or volumes with fresponse collect are just that. They're full byte-for-byte flat disk images, similar to something that you would get through either a DD or any standard forensic tool. We'll go ahead and select Disk 2 and add it into our collection and essentially instruct that remote machine to make an image of that device. Once we press Next, we'll get a summary of the information for this collection, what we've configured, the collection name, the subject or subjects, and the devices that we'd like to see collected. Pressing Finish creates the actual collection on the server. Subjects will periodically connect to the server based on the interval you designate. When they connect, they'll see if they're needed in a collection based on their host name. Double-clicking on this collection gives us the details, including the total number of subjects in the collection, how many are complete, who created it, and when. Selecting an individual subject gives us the details about that subject, its name, its state, the destination where the image data will be stored on our server, as well as the last network address and last time it was seen. When the subject pumps data to the server, it does so in a fully resumable manner. So if the subject loses connectivity at any time, either by dropping off the network or by becoming unresponsive, it will essentially resume within 50 megabytes of where it left off once it restarts. We'll go over what that looks like today. But here you can see by selecting the device itself, I can get the name and the state and the offset size and the percentage complete of that imaging operation. Hashing data and the like will populate once the image is complete. So you can see where we're sitting at roughly 13-14% on the image. We're going to go to that subject now and switch to a different desktop, and we're going to simulate what it would be like for that subject to lose access to the network or be rebooted. I'm going to simply right-click and disable the network interface. Now, in a normal collection operation, this would be a cause for concern, as we would most likely have to resume the collection from the beginning. However, fresponse collect doesn't function that way. It maintains sort of a state table as to where it is. Even if the machine is fully rebooted and restarted, the remote server maintains the requisite information to resume. Here you can see there's no forward momentum on the collection. The last seen time hasn't changed, and neither has the percentage. Returning to the subject, we'll simulate restarting it or regaining access to the network by re-enabling this network interface. Now, what's important to note is I don't have to do anything. I don't have to restart the image. I don't have to go to the server and check a sequence of boxes or tell it to perform any steps. The subject, based on the interval we designate, will reconnect to the server, realize that it was needed in a collection, realize where it left off within roughly 50 megabytes, and automatically resume. And here you can see the imaging percentage has jumped to 20 and now 21 and continues to climb. So fResponse Collect is able to do imaging operations, disks, volumes, physical memory, custom content images and profiles over a robust or a volatile network connection. This allows you to do imaging operations over the internet, or in situations where you do not have VPN connectivity between you and your remote subjects. All right, so let's talk briefly about the rest of the features that make up fResponse Collect. As I indicated before, we have the ability to collect data from what we call agentless connections, cloud servers, and cloud files. We'll go ahead and press OK and dismiss this display. The image still running in the background because it's communicating subject to server, not to us. But agentless connections are just like they sound. They are remote file shares. They are operations or places that we would be able to collect individual file and folder content from. Things like SFTP and SMB shares. Cloud servers are snapshot images of things like Amazon and Azure servers, and cloud files would be data from cloud storage environments. So I'll start with looking at an SFTP share. Think of this like a remote Apple machine, which makes sense because thanks to Apple's system integrity protection, full disk imaging is quite difficult. I can double click on this account that we've configured and then select a specific directory. In this case, this is a remote Linux machine, and I'm going to select the boot directory. So what this means is that our software will now collect all of the file contents in the boot directory and every directory underneath it recursively. It will save those contents to this data directory, this data drive rather, that I've designated, and it will reset their dates and times commensurate with the dates and times that the original file system possessed. Over in Activity, you can see that operation as it's ongoing. We'll be connecting, copying files, updating that interface accordingly with details as we go. In addition to agentless connections, we do give you the ability to collect data from cloud servers. In the cloud server environment, essentially what we're talking about is creating snapshots of live or offline remote cloud servers hosted by either Amazon's EC2 or Azure Compute. When I double click on an account at Amazon EC2 that I've configured, it gives us the ability to select a volume ID based on its instance ID and of course its size. This would instruct a remote worker process, or rather a local worker process, to snapshot the remote machine's device, to then image that snapshot and delete the snapshot upon completion. So what we would end up with is very much a full bit-for-bit image of the remote machine, whether it is offline or online. And this option is available both for Amazon EC2 and for Azure Compute. Lastly, cloud files. Using fResponse Collect, we can pull data from a number of different cloud storage environments. Amazon, Azure, Box, Dropbox, Office 365, G Suite, Google Workspace is formerly G Suite. We have an Amazon account configured for S3, so we're just going to go ahead and select a bucket. Just like before, I could select a specific directory, like I did with the boot directory, or I could collect the entire bucket's contents, or filter the contents based on something that might appear in the file name. For the sake of expediency, I'll just select the entire bucket and give it a destination. Once again, we'll have a new process that'll spin up. That new process will begin talking to Amazon. It'll start enumerating file and folder content, and then begin downloading that content, resetting the dates and times commensurate with the dates and times that Amazon provides. S3 only provides a last modified time, so the accessed and created times will be zeroed out. If you were to look at that data in a forensic tool or e-discovery tool, depending on the tool you use, those file times will either be sometime in the early 1600s or 0. You'll receive the files along with a CSV in the destination directory in a folder automatically generated for the collection. So you can see with fResponse Collect, you have the ability to get data from a number of different sources: cloud files, cloud servers, as well as agentless connections, and the ability to create long-distance image operations that can withstand drops in network connectivity, reboots, and changes in network state. We'll go back to the Collect server briefly and just take a look at our collection to show you that it is still ongoing, whether we were watching it or not. So here you can see our subject and the individual device in question, and the percentage is now at 79. When the image completes, it'll update both the MD5 and SHA-1, and you'll have the ability to download that image as a flat file either a DD or an image style file format. Essentially accessible in any computer forensics or e-discovery processing tool. All right, this gives you a good overview of fResponse Collect, what it does, and why it's useful. For more information, find us on the web at www.f-response.com or send us an email at sales@f-response.com. Thanks. We look forward to hearing from you. Have a great day.